In this video, you will learn to find area of the region between intersecting curves and area of the region between two non-intersecting curves over the interval AB. Let's say we want to find the area of the region between two curves. And the curves are y is equal to f of x and y equal to g of x. So you take the following steps. Number one, graph the curves represented by this function y equal to f of x and y equal to g of x. So that's the first step here, graph them. The second step, you determine which curve is above the curve. Let's say in this picture f of x is above g of x, which means f of x is higher than g of x. F of x is greater than g of x. So then you find the function that represents the difference between two curves. In other words, subtract this smaller function from the bigger function. And then you integrate the function over the interval a to b. So this is the formula. So you subtract the function which is lower or smaller from the function which is higher or upper, and then you integrate from the intervals, whatever the interval is given to you. Here we have an example. It says write a definite integral that represents the area of the region. So we have y1 equal to x squared minus 4x plus 3. So that's basically this curve. And the y is equal to y2 equal to minus x plus 2x plus 3. It looks like this curve. So let's say y2 is above the y1. So, and they are intersecting at this point 0, 3, and I think 3, 0. So here x is 0, and here x is what? 3. So we're going to subtract y1 from y2. So we do that one, and we inside the formula area would be a to b y2 minus y1 dx. And from the picture you saw the a is 0 and y is, like this is x value, x is 0 and x is 3. And here y2 equal to minus x squared plus 2x plus 3, and y1 is x squared minus 4x plus 3. So we open the parentheses, so distribute a negative sign. So you will have a negative x squared plus 2x plus 3 and negative x squared plus 4x minus 3. So we simplify and we get integral from 0 to 3 minus 2x squared plus 6x. And since the question says do not evaluate, so that's the answer you're going to input on the web assignment. Example 2. So here we're going to sketch the region bounded by the graphs of the equation and find the area of the region between this y is equal to x minus 2 and y equal to x squared plus 1 and x equal to minus 1 and x equals to 2. So let's first step 1 is we graph y is equal to x minus 2. So here we can create a table. So here x and y, we can choose x equal to 0, substitute, it becomes 2 times 0 minus, which is negative 2. So you get a point 0, negative 2. Then you pick another point, let's say I pick 2, so it becomes 2 times 2 minus 2. So it'll be 2. So second point is 2, comma 2. So we plot this one, these 2 points, 0, negative 2, and 2, 2. So you get this kind of line. Okay, so now we graph the second equation, y equals to x squared plus 1 in the same x vector. So we can create another table, and remember this is a quadratic function and domain is all real numbers. So you can pick negative, 0 and positive. So let's pick negative 2 and substitute. Negative 2 squared plus 1 is 4 plus 1. Now remember, when it's square and negative, it becomes positive. Okay, don't forget that. So we have point negative 2, 5. So we plot -2, 5 and this here. And then we pick 0, and we pick 0 here, and 0 square plus 1 is 1, so we get 0.1, so it's second point. And then you pick 2, and you come 2, 5 in this point. Connect these 3 points, and you get a parabola. So we have a graph of line and graph of quadratic function. Okay, now we sketch the x equal to -1. So that's x equal to -1, and then x equal to 2, and we shade this region. So now you can see between x is -1 and x equal to 2, the y is equal to x squared plus 1 is over this y is equal to 2x minus 2, which means x squared plus 1 is bigger than 2x minus 2. So we're going to subtract this from this one, and we integrate from this x values to this x value, from -1 to 2. So we have area now, -1 to 2, f of x minus d of x. The f of x is x squared plus 1, d of x is 2x minus 2. Again, open the parentheses, and remember this negative make it positive. Now we combine the like terms, and you have x squared minus 2x plus 3. Now we apply the power rule of integration. We integrate, so it becomes x. You add 1 into 2, 2x3 over 3, and then x squared over 2, and then the integral of 3 is 3x. And now you have to substitute from -1 to 2. Okay? So first you're going to substitute 2 in this one. So we got 2 cubed over 3 minus 2 squared plus 3 times 2, and then you have to subtract. And since there are more than one terms, you can put in parentheses. So you substitute -1 cubed over 3, and then -1, the -1 squared. Remember here 2 and 2 cancel out. And then plus 3 times -1. So now we simplify. So 2 cubed is 8, so 8 over 3 will be 4, 3 times 2 6, minus, now the cube of -1 is -1, so -1 over 3. So this is square of -1 is 1, and this is 3. Okay? So basically it keeps simplifying. 8 cubed over 3 plus 6, and now we open the parentheses, so it'll be plus 1/3 plus 1 plus 3. Now we combine the whole numbers. So it'll be -4 plus 6 is 2, and 2 plus 1 is 3, and 3 plus 3 is 6. And similarly combine the fraction because same denominator, 8 plus 1, 9 over 3. 9 over 3 is 3 plus 6, so the area is 9. So here we have an example 3. We're going to write and evaluate definite integral that represents the area of the region bounded by the graphs of the function and the tangent line to the graph at the given point. So in other words, we have a function, this one, we need a tangent line. So then we're going to find the area bounded by this function and the tangent to this at this point, -1. So first thing we're going to do is find the tangent line. So we find the first derivative, so f prime x is 1 minus 3, so x becomes 1. So derivative of x cubed is 3x squared. And now we substitute x value, x is -1. So remember first derivative is slope, so that means f prime evaluate at -1. 1 minus 3, -1 squared. So it becomes 1 minus 3 times 1, so 1 minus 3 is equal to -2. The slope is -2. So now equation of line, the formula is y minus y1 equals tan times x minus x1. Now we substitute x1 is -1 and y1 is 0 from this point. And the slope is -2, so we have y minus 0 equal to -2 times x minus -1. So we simplify, so we get y equal to -2x plus 2 is the equation of tangent line. So now we're going to graph this function and this tangent. Okay, so let's sketch the graph of f of x equal to x minus x cubed. So we can make a table. Again, it's a cubic function, polynomial function, all real numbers, the domain is. So you pick some negative numbers, some positive numbers. So I picked -2 and I substituted -2 minus cube of -2. And you can simplify, remember cube of -2 is -8. So minus minus plus 8. So -2 plus 8 becomes 6. So the first point, -2 comma 6. Now we substitute -1. Similarly, cube of -1 is +1, but then multiply with negative become -1. So -1 and -1 would be plus, it becomes 0. So the second point, -1 comma 0. Then we substitute 0. So we got 0 minus 0 cube is 0, and then 1 is 1 minus 1 cube is 0, and 2 minus 2 cube is -6. So these are the points we substitute, and this one. So that's curve. This comes out. And then sketch the tangent y equal to -2x minus 2. So since it's a linear function, you need 2 points. So we pick x equal to -1. So you got -2 times -1 plus 2, which becomes, I think, 0. Then x equal to 2, and we got negative times 2 times 2 minus 2 minus 6. So the second point, 2 negatives. So you got this tangent. Okay. So I think this is the region we had to find so that we can shade it. That's the area we're looking for. So you can notice from the graph that f of x equal to x minus x cubed, and the y2x intersect when x equal to -1 and x equal to 2. And the graph f of x is above the graph of the tangent from -1 to -2. So therefore we subtract the tangent graph from the given function graph, which is f of x minus dx. And so this is basically a formula, a to b minus the function which is above the other function, or the function which is greater than the other function. So here f of x is x minus x cubed, g of x is -2x minus 2. As usual, put parentheses whenever you're subtracting and you have more than one term. Now we distribute. So negative becomes 2x plus 2. Now combine the like terms. Okay, so now we integrate using the power rule of integration. X to the n is x to the n plus 1 over n plus 1. So now we have a negative. This, so 3 plus 1 is 4x to the 4 over 4 plus 3 times this to be x to the power 1 plus 1, 2, and divided by 2. Constant, the integral of constant is constant times x. Now we have and indicate the limits -1 to 2. First you substitute the upper limit, 2. So this becomes -2 to the 4 over 4 plus 3 half times 2 squared. And it's going 2 times. Now subtract always. Start with the parentheses because you have more than one term. And negative, and x is -1 to the 4 over 4 plus 3 over 2 -1 square plus 2 times -1. And then we simplify. So 2 to the 4 is 16 over 4 is 4 -4. 2 square 4 is 4 over 2 6. 2 times 2 is 4 and -1. And 4 apart -1 is 1 over 4. So this becomes -1/4. 3 half. Square of -1 is 1. Plus 2 times -1 is -2. So it's simplifying. So I think this 4 cancels. -4 and it has 6, and this becomes -0.75. So it becomes plus 6 plus 0.75. So the area is 6.75.